Good morning. Let's talk about number 45. 45 is here. It says a 35 milliliter sample of 0.15 molar acetic acid is titrated with 0.15 molar NaOH solution. Calculate the pH after the following volumes have been added. A is 0 milliliters, B is 17.5 milliliters. So I'm going to go ahead and do A and B for you, and then that way you can kind of see what the process is like, and then it will be pretty easy to plug the rest of these in. So starting out with this problem, the first thing I always do is write out everything that I have, right? So chapter 17, number 45, A. So for A, I have 35 milliliters of 0.150 molar CH3COOH and 0.150 molar NaOH. And for A, we're going to have 0 milliliters. Maybe I'll also just write out how many liters this is, because later on in the equation I know milliliters doesn't do much for me. So this is equivalent to 0.035 liters and obviously 0 liters. Okay. So for this equation, because I'm not adding any NaOH, this is just a straight up equilibrium problem. And so all I need to do is plug everything into an ICE table for the breakdown of CH3COOH. So I know when acetic acid CH3COOH breaks down, it's a weak acid, and it breaks down into CH3COO minus and H plus. So let's get our concentrations out. So I have 0.150 molar, 0 and 0. This is going to change by X. Because this is a weak acid, I know this X isn't really going to do much here, so in my equation, when I solve for H plus, I can just ignore it. This will be X and X. I look up the Ka in the appendix D, and it's 1.8 times 10 to the negative fifth, and I know this is going to be equivalent to X squared over 0.150. When I solve for X, I get 2.7 times 10 to the negative 6. So that's X squared. Take the square root of both sides. Solving for X gives me 1, 2, 3, 4, 5, 2, 7. Oops. There you go. X equals 0.001643, etc. And I'm just going to take the log of that right away. So my pH, negative log of my X, is 2.78, and that's my pH. Okay, so that's just an equilibrium problem. So equilibrium, the pH is 2.78. Now let's start adding some some base, NaOH. So for B, I still have 35 milliliters of 0.150 acetic acid, which is 0.035 liters. But now I'm going to add 17.5 milliliters of 0.150 molar NaOH. And again, that's 0.0175 liters. Okay, that's just going to help me do my equations. So So for this one, I can't just do a straight up equilibrium table. I have to do the bad table, right? So it's before addition, after addition, or what the addition is, and after addition. And let's set up our equation for the dissociation of acetic acid with NaOH. So when this breaks down, we're going to get CH3COO minus and H2O. So this time we have, because we have different volumes of what we're adding, we actually need to just solve for the moles first before plugging it into the table. And after we plug everything into the table, then we're going to solve for molarity by figuring out the total volume here. So let's go ahead and do our math down here. So we have 0.035 moles per liter of 0.150, oops, sorry, 0.035 liters of 0.150 moles per liter. And that's going to give us 0.00525 moles of acetic acid. We also have 0.0175 liters of 0.150 moles per liter NaOH. And that is going to give us 0.0025 moles of NaOH. So let's plug this all into our table. So initially we have 0.0525 1 second. This will be continued on part 2.